Okay, Mr. Precella, continuing to work on the review for the Math 1324 face-to-face final exam review. Okay, this is for my face-to-face class, not my online class. So I'm going to start doing some word problems here. And let's see. Problem number 10 deals with cost, revenue, profit. Midtown Delivery Service delivers packages which cost $2.80 per package to deliver. The fixed cost to run the delivery truck is $192 a day. So it costs $192 just to run that truck, whether they're delivering one package or two packages. Maybe they're leasing the truck by the day, who knows. If the company charges $5.80 per package, how many packages must be delivered daily to make a profit of $54? Well, there's a lot of things going on here, and this is some of that very first stuff, the way we began the semester, dealing with cost, revenue, and profit. Revenue is the amount of money that a company takes in. And to calculate the revenue, to write a revenue function, it's the selling price times the quantity. I think I probably would have used a taco stand. If you had a taco stand and you were selling tacos for $3 a taco and you sold 50 tacos, then how much money did you take in then? Well, $3 times 50, $150. This lowercase p, let me write that out. It's the selling price. I don't want that to look like a capital P, which is how we denoted profit. Now, cost functions are a little bit more involved. The form for a linear cost function looks like y equals mx plus b. Somewhere along the way in your algebra life, you graphed or you looked at slope-intercept form for a line, y equals mx plus b. And that's how our cost functions look, except we don't use the phrase slope and y-intercept. This m here is called the marginal cost per item. If you were making those tacos, it might be the cost of the supplies. Okay? For every taco, you've got to buy the supplies to make it. Okay? B, in algebra, we call that the y-intercept. Here in junior economics or junior finance, we call it the fixed cost. So if you had that taco stand, you would have to buy the supplies. That would be the marginal cost, because it depends on how many tacos you're going to buy, how many supplies you make. And the fixed cost, that would be like the rent on the building or the rent on the taco truck, what have you. And profit is what you have left over after all the costs. Profit is the revenue, that's the amount of money you take in, minus that cost function. When you're calculating revenue, you're going to need to distribute that minus sign all the way through. Now to actually start doing number 10, let's see. This problem talks you through all three of these functions. It starts off giving you the information that you need in order to write the cost function. Okay? So this is problem number 10, the cost function. This delivery service delivers packages which cost $2.80 per package to deliver. So maybe that's how much the delivery boy gets of the money. Okay? The fixed cost to run the delivery truck is $192 a day. So to write just the cost function, the $2.80, that's the marginal cost. $2.80 times the number of packages plus $192. For instance, if they only delivered one package one day, they would still have to pay the $192 for the truck rental or whatever this money is that it costs to run the truck, and the $2.80 for the one package they delivered. Okay? So that's the cost function. The next piece of information tells you how to write the revenue function. They're charging $5.80 to deliver these packs. So that's how much money they're taking in from the people that are getting them to deliver. This isn't some big company like UPS or anything. It's just a small midtown delivery service. So the revenue function is $5.80x. We want to know how many packages must be delivered to make a profit of $54. Use these to find that profit. Profit is revenue, that's the 5.80x, then minus the cost. The cost is the 2.80x plus 192. Notice the way I put that in parentheses. Let me lift this up. Because we need to distribute this minus here. You want to subtract all of these costs, not just the marginal cost. You need to subtract the fixed costs also. So distribute this minus, and here's our revenue function. Profit function. 5.80 minus 2.80, would that just be a 3x there? And then we're distributing this purple minus here. It might look black up there. Distributing that purple minus, this would be a minus 192. Still haven't answered the question yet. What was the question? It asks, okay, how many packages must be delivered to make a profit of 54? So we've gotten as far as writing the profit. So set the profit function equal to 154 and solve it for x. How would I go about solving this equation for x? 3x minus 192 equals 54. Okay, move over that 192 by adding 192 to both sides. So we'd have 3x equals, is that a 246? And then divide both sides by 3. So how many packages do they need to deliver every day to make a profit of $54? Well, 82 packages. So they need to deliver 82 packages a day, and that'll get them a profit of $54. Okay? Any questions there? I'm sort of missing this. There was a semester where I did this all semester long, and that's where the class videos came from. Okay? Oh gosh. Number 11 begins the financial math with the little formulas. Okay, so let's review. Well, the simple interest formula, I equals PRT. I'm not even sure if that pops up on here. We have the periodic compound amount formula. Effective rate, I'm not sure if that's on here, if it wound up on this or not. I don't think it did. And then we have the annuities. Annuities require a series of equal periodic payments, like a house payment or a car payment, or saving for retirement. Every month saving $100 in some account. That would be an annuity. Okay, but it's a series of equal periodic payments. It's got to be at an equal period. You can't just, okay, whenever I can, I put money in an account, and no, that wouldn't be an annuity. Putting $100 a month into an account every month, that's an annuity. So, annuities assume periodic payments. If there's not just a series of periodic payments and it's a compound interest problem, then we're using the periodic compound amount formula. Okay, so let's see. Need another sheet of paper. Let's read through. Oh, heck, the first few problems, 11, 12, 13, 14, those don't look like any where we got to actually do any number crunching on them. It's just asking you which formula is it. So, oh, another thing I didn't mention, ordinary annuities have the payments made at the end. Annuity due have the payments made at the beginning. Okay? Most annuities are, ordinary annuities. Okay? The annuity dues aren't that common. So that's why we didn't ever bother working with a present value of an annuity due problem. Okay? So this is a formula sheet that's posted under document sharing, and you might want to put some of these formulas on your index card for this class. Okay? This semester, for the final exam this semester, spring 2016, how many index cards should we use? 2?
5.
No, let's just go with 2. I'll agree to 2. So 2 4x6. This is spring 2016. So if you can write, formulas or examples, whatever you want on them, but 2 4x6 index cards this semester, spring 2016, face-to-face class. Okay. So let's read number 11. A woman deposits $5,000 at the end of each year for 3 years in an account paying 8% interest compounded annually. To find the amount she will have on deposit, it's assumed she means at the end of the 3 years. Which finance formula should we use? Okay. Well, even if this would work, even if it weren't for how much will she have in deposit after 2 years? Which formula would you use? Well, first of all, is this an annuity? Is she making a series of equal periodic payments or deposits? Yes. She isn't just making one deposit. Okay, if she were just making one deposit, it'd have to be periodic compound amount. But she's making a $5,000 deposit at the end of every year for 3 years. So this is an annuity. Okay, what are we trying to find? If it's an annuity, are we trying to find the present value or the future value?
Future.
The future value. Okay, so on the sheet, it's an annuity, future value. There's 2 future value annuity formulas. Is this an ordinary annuity or an annuity due? Let's see. Does it say the word end or beginning? It says end. Oh, okay. So let's see. It sure doesn't say beginning. In order for you to use an annuity due formula, it's got to say the word beginning, or else it's got to say this is an annuity due. Okay? So this one, it says end. She's depositing these more than once, and we're trying to find out how much money is in the account. We assume at some point in the future. When she opened the account, we assume it was 0. Finding the present value would be meaningless. Okay, so which one is it? Future value of ordinary annuity? B. Now, problem number 12. A man is establishing a fund for his son's college education. He wants to know what lump sum must he deposit in an account that pays 5% compounded monthly, in order to have $85,000 in the fund at the end of 10 years. So which finance formula would he use for this? Oh, yeah, you're right. My thoughts are, when I see this, is this an annuity? How many deposits? Is he making a series of deposits or just one deposit? What lump sum must he deposit? Okay, that sounds like he's just making one deposit, which means it's not an annuity. We're told he wants to have $85,000 in the account at the end of the time. Well, the fact that there's just one deposit, that knocks out every annuity formula. B is right, the periodic compound amount formula. That periodic compound amount is the one that you use when there's just one deposit, one lump deposit, then the money just sits there. If he were going to be putting money in the account every month, saving for the son's education, then no, that would be an annuity. But no, here he's just making one lump sum deposit. Okay. Any questions? Number 13. You want to take out a loan to buy a new car. Okay. For which you need to finance $27,452. The bank will give you a loan of 6% compounded monthly. You look at your budget and decide you could afford $252 a month payment. Which formula should you be using? Okay, to figure all of this out. It's not asking you to actually decide. That would be a little bit messy, but it's not asking you to actually solve the problem, just which formula would you use? What is this an example of? Well, my first thoughts are, is this an annuity? Is there when he's making a car payment, is there going to be a series of equal periodic payments? Oh, yes. So this is an annuity. We're told that he's going to finance $27,452. Is that a present value or a future value? Present? Yes, that's correct. This is the amount that he's financing today. At the end of the however many years he's going to have it, oh, that's what we're going to try to find. But at the end of the loan, we hope the balance is what? Zero. That's what we're hoping for, okay? So this is a present value annuity. There's only one present value annuity problem, and which one, or formula, and which one is it? Present value of an ordinary annuity. Okay. Software will go through and maybe it'll change numbers and so forth, but it still keeps the problem basically the same, even if it changed the amount of he's financing and changed the interest rate and the payment. It's still a present value of an ordinary annuity formula. Now, by the way, y'all should know this, but I'll say it anyway. Just because all three of these have been B doesn't mean on your test they'll all be B. This is just randomly arranged letters. Now, number 14. A woman deposits $5,000 at the beginning of each year for 3 years in an account paying 8% interest compounded annually. Which formula should you use to find the amount you'll have in deposit after the 3 years? This problem is very similar to number 11. So number 11, it says, okay, she's making the payments at the end of the period. On number 14, it's beginning. First of all, is it an annuity? Yes. There's only one annuity formula that involves an annuity due, the beginning time period, future value of an ordinary annuity. If you want to find the amount of money in the account 3 years in the future, that would be future value of an annuity due. Not a lot of work to these. Future value of an annuity due, so that one's D. So they're not all B. That's the moral to that story. Any questions? Let's do number, are we ready to do number 15? Okay, now this is where we actually start plugging in numbers. So on this one, number 15, in order to purchase a home, a family borrows $92,000 at 9.4% for 15 years. Since this says what's the monthly payment, and the instruction said find the monthly house payment, you'll always assume that this interest is also compounded monthly. Okay, if it's a monthly house payment, then the interest is compounded monthly. So it didn't say 9.4 compounded monthly, but it is. So if we think of a timeline, this family's borrowing $92,000. That would go where on the timeline? Is that a present value or a future value? Present value. That's the amount of the loan today. At the end of the 15 years, we hope the balance is zero. Right? Hopefully they paid off the house, not refinanced it a dozen other times, and still owe $92,000 on it. Well, is this an annuity? When you're making a house payment, is this a series of equal periodic payments? Yes. So which formula is a present value annuity formula? There's only one of them. Present value of an ordinary annuity. Okay? That's what you use for calculating house payments, car payments. Which problem was it that had something with the car payment? Number 15? No, number 13. A person making a car payment of $252 a month. So that was present value of an ordinary annuity. So I'll make a note. PVOA for present value of an ordinary annuity. And I'll go ahead and write out that 9.4% monthly. So the present value of an ordinary annuity formula is P equals R times 1 minus 1 plus I to the negative n all over I. It's been a while since we've used these formulas. Remember what the variables stand for? That's why they're just stated up here. The P is the present value, R is the payment, lowercase I, that's the interest rate per period. It's the stated rate divided by the number of periods per year. N is the total number of periods. There it is, right underneath it. N is the total number of periods, which is the number of periods per year times the number of years. On this one, P is 92,000. R is what we're trying to find, that payment. To get I, we normally divide. So I is 9.4% compounded monthly. It's been a while since we've done one of these. You write that 9.4% is a decimal, 0.094, divided by what? 12. So let's see, what's 0.094 divided by 12? punching that into my calculator. Ooh, it's one of those things that doesn't terminate. 0.0078, and the threes go on and on. Let's see. Can't see it. 0.00783333. I'm just going to put maybe there. Now, I couldn't do this when we were doing it in my math lab because the way you had to be exact to the very penny. But here, since it's multiple choice, I can round a little. And so I'm just going to write it as 0.0078333. And so we might be a couple of cents off on here, but that's okay. To get n, we multiply. To get I, you divide. To get n, you multiply. This is the total number of periods. How many monthly periods will there be in 15 years? What two numbers am I going to multiply? 15 times 12, that's 180. So on a 15-year house loan, you're going to make 180 payments. So I'm plugging in 92,000 for the P. The R I don't know. 1 minus 1 plus I. You know, remember, I normally just do that in my head. The 1 plus all of that would be 1.0078. And how many threes did I write down? 3 of them? To the negative 180 all over I, 0.0078333. So I'm going to punch in the bracket number and then do what? Multiply or divide to get R? Divide? Let me see. Now blind y'all with the glare again. Let me see. Sometimes over here works better. Okay, I'm punching in the bracket number. I'm going to do the top and then hit enter to get an answer and then divide it by the bottom. 1 minus 1.0078333. Do I remember how to raise those exponents? It's a little carrot top. Ooh. Right there. It's hard to see. Raised to the negative 180. Enter. Divided by 0.078333. Oh yeah, thanks. 0.0078333. And now I'll divide 92,000 divided by that bracket number. Enter. That bracket number is significant. That's how many payments it takes to actually pay off the 92,000. So it looks like there were about 96 payments pay off the 92,000. How many payments were there altogether? There were 180 payments. So it's about 84 payments that are interest. Okay? So $955, and I'm getting 14 cents. I might be off a couple of cents just because the way I rounded, and also the way this calculator calculates those negative exponents is slightly different from how the software calculates them. But on this one, no, okay, exactly right. 955.14. Any questions there? Let's see. What about, I wonder if, do we have time to do one more? Number 16. Here's what okay, I think I'll take a break right now.